Captions in English, please. So this is the fourth video of chapter 7. We will write a molecular and complete ionic equation and then net ionic equations. So a molecular equation is an equation showing the complete neutral formulas for every compound in the reaction. And so up to now, that's what we have seen. For example, Hg2SO4 aqueous solution plus 2 NaCl, another aqueous solution, react together to make Na2SO4, another aqueous solution, plus 2 AgCl, a solid. So that's a precipitation reaction here. And so we call this a molecular equation because it shows all the compound formulas. But a molecular equation does not really accurately show what the solutions look like. They are not intact molecules floating around. That's not the reality. So we need to write a complete ionic equation to show aqueous ionic compounds that normally dissociate, so that are soluble in solution, as they are actually present in solution, so as ions. So the complete ionic equation will show ions as they are in solution instead of the compound, However, the precipitate or the liquid or gases will remain intact. These are not dissociated, so they will stay as, the formula will stay the same for them. So in the example above, if we change it into a complete ionic equation, it becomes 2Hg plus, coming from HgSO4, Hg2SO4, and then 1 SO4 negative 2 ion. So the 2 Hg plus and the sulfate form the Hg2SO4. Then the 2 NaCl become 2 Na plus 2 Cl minus. And it's all aqueous because they are all ions floating around in water. Then Na2SO4 becomes 2 Na plus and plus the sulfate ion again, all as aqueous. However, the 2 AgCl stays as 2 AgCl because that's a solid. And so solids are not dissociated. They are actually, bonded into a solid. So that's more appropriate to keep the compound formula here. So in the complete ionic equation, some of the ions in the solution are the same on both sides of the reaction arrow. And so these ions are called spectator ions because they do not participate in the reaction. So if we look at the complete ionic equation again, you can see that on both sides you see the sulfate ion, SO4 negative 2, the same exactly on both sides. Another thing that is the same is the 2 Na plus, same on both sides. So these Na plus and SO4 negative 2 are spectator ions. Spectator because they do not participate in the chemical reaction. They are not involved. They stay the same before and after the chemical change. And so to simplify the equation and to be more clearly showing what is happening, spectator ions can be omitted. So those sulfate and sodium ions here that are repeated on both sides without changing can be taken out. And so then the equation becomes 2 Ag plus 2 Cl minus gives 2 AgCl solid. And so because it's 2, 3 coefficients of 2, we can omit them and it becomes Ag plus aqueous plus Cl minus aqueous gives AgCl, the solid, the precipitate. So this reaction comes down to just having the silver ion reacting with the chloride ion and making the solid or the precipitate AgCl. And so equations such as this one, which show only the species that actually participate in the reaction, are called net ionic equation. So that's the net ionic equation for the previous equation we looked at. So to summarize, a molecular equation is a chemical equation showing the complete neutral formulas for every compound in a reaction. A complete ionic equation is a chemical equation showing all the species as they are actually present in solution. So it shows the ions if you have ions. And then the net ionic equation is an equation showing only the species that actually participate in the reaction. And so it omits the spectator ions, those that are not involved in the change. So let's go through this concept check and practice writing those. So use the reaction below to answer the questions that follow. So in words, we have lead 2 acetate solution reacting with ammonium chloride solution. So these two are the reactants, and we need to find out the product of the reaction. So first question is to predict the product. So for this, you want to find out what are the ions in those solutions, because we have 2 solutions as reactant, which means it's only ions in there. So lead 2 here indicates that it's Pb2+. Pb is the symbol for lead, and the Roman numeral 2 indicates 2 positive charges. Acetate. The acetate ion is a polyatomic ion made of carbon, hydrogen, and oxygen. And its formula is C2H3O2 with 1 negative charge. So you can check that in your list of polyatomic ions and verify this formula for the acetate ion. Then in the ammonium chloride solution, we have the ammonium ion. Ammonium is one of those polyatomic ions you need to remember. It's NH4+. The chloride ion comes from chlorine, group 7A. So 7 minus 8, it has 1 negative charge. So to predict the product of the reaction, we need to exchange the partners. And so the positive Pb2+ now will go with the chloride. And then the ammonium ion will go with the acetate, because you need to have the positive ions go with the negative ions of the other compound. So if we look at these and make the formula of the product, so we have Pb2+ and Cl-, always write the cation first, then the anion. You can see if you do the crisscross trick that the 2 from the positive charges of lead will become a subscript for chlorine, and the Pb will have a subscript of 1, which is omitted. So the formula will be PbCl2. The other combination makes ammonium combined with acetate. Ammonium is the positive ion, so it goes first in the formula. And so here you see that ammonium has 1 positive charge, the acetate has 1 negative charge. So one of each ion will make a neutral formula. And so the formula is NH4C2H3O2. We keep it this way. We don't add the hydrogens together because we want to show that it's the ammonium and then the acetate ions bonded together in an ionic compound here. So it's best to keep it this way so we can recognize the ammonium and the acetate. So is there a precipitate that forms? That's question B. Which rules apply? So we need to find out the solubility for those 2 products, PbCl2 and NH4C2H3O2. So let's look at the solubility rules. So we have PbCl2 and NH4C2H3O2. We can see here NH4+ and C2H3O2 are both in the mostly soluble compounds, and there is no exception. So this compound of ammonium acetate is definitely soluble. And then PbCl2, we don't have any Pb listed on the left side here. So however, we have the chloride ion with the bromide and the iodide there. It's also mostly soluble compounds that have the chloride ions, but there are exceptions. So let's read the exceptions. When any of these ions pair with silver, mercury, or Pb, the compound is insoluble. And we do have PbCl2, so that's insoluble. So let's write this here. Is there a precipitate that forms, and which rules apply? Well, the acetate and the ammonium make only soluble compounds. There is no exceptions with those 2, so they will make a soluble compound together. And then the chloride ion makes soluble compounds, except with Pb2+. So is there a precipitate that forms? Yes, we have a solid that's PbCl2. So write the balanced molecular equation now. So we have our product formulas, but we do not have the reactant formulas. And here, lead 2 acetate will have, one Pb2+ with 2 positive charges, and the acetate has 1 negative charge. So you need 2 acetate per Pb to make it a neutral formula. So that's going to be Pb, parentheses C2H3O2, close parentheses 2. So 2 acetate per lead. That's a solution, so it's aqueous. Then the ammonium chloride. Ammonium, 1 positive charge. Chlorine as an ion has 1 negative charge. One of each will make a neutral formula. So it's NH4Cl, also an aqueous solution. And then they react together to make PbCl2, and that's a solid. We've seen how it is insoluble. Plus the ammonium acetate, NH4C2H3O2, and that's also an aqueous solution because it's soluble. So let's write the complete ionic equation now. Oh, sorry, we need to balance the molecular equation first. And here we have 2 acetate in the reactant Pb acetate. You know, the lead acetate has 2 acetate, so we need 2 acetate on the right side. And for this, we need to put a coefficient of 2 in front of ammonium acetate. That makes 2 acetates and balances the acetate. However, it makes 2 ammonium ions on the right, and there is only 1 on the left. So we need a 2 in front of NH4Cl to balance the ammonium. So that balances the ammonium, and we can see that it also balances the chlorine because now we have 2 chlorine on the left and there is 2 chlorine on the right in PbCl2. With those 2 coefficients of 2, we have a balanced molecular equation. So let's write the complete ionic equation now. So we have the ions, we know them from what we wrote in question A. So we have Pb2+, that's an ion in solution, so aqueous. Plus 2 acetate, there is 2 acetates per lead, so 2 C2H3O2 -1, and that's also aqueous. Ammonium chloride, we have 2 ammoniums and 2 chloride ions because of the balancing, we need 2 of those, 2 of each. That's aqueous. So make PbCl2 the solid, and here it's a solid, so it stays as PbCl2. It's not dissociated, it's actually bonded into a solid. And then we have the ammonium acetate giving 2 ammonium ions and 2 acetate ions. Both of them are aqueous because they are ions. So that's the complete ionic equation. In that, we can see that we have some repeat from the left to the right. We have ions that stay the same. For example, the ammonium and the acetate. We can see that we have 2 of each, and they don't change. They stay the same from left to right. So we can omit them. And when we omit them, we can write then the net ionic equation as follow. So Pb2+ aqueous plus 2 chloride ions aqueous give PbCl2 solid, the precipitate. And that is the net ionic equation, summarizing what is actually happening when you are mixing those 2 solutions. You're making a precipitate.